Alright class, so today we are talking about inverse trig functions. So we've learned about inverses before. We can have one function and we know how to find the inverse of it. So in this section you'll be able to evaluate inverse trig functions for sine, cosine, and tangent. You'll also be able to solve trig equations using inverse trig functions, and then you'll be able to find the composition of a trig and inverse trig function. Alright, so recap. Remember, only functions that are one-to-one have inverses. What does that mean? It means our function must also pass the horizontal line test. That means it's one-to-one, and then that also means that it has an inverse. And so we're talking about inverses of our trig functions, and the first one we're going to start off with is sine. So let's talk about the sine function. We know how to graph this, so I am going to do a little sketch of our sine function. Go up to 1, down to -1. Gonna put the usual x values like pi over 2, pi, 3 pi over 2, 2 pi, and so on. I'll also go to the reverse, or the negative side. And so on. Okay, so we know how to graph this. Sine goes 0, 1, 0, -1, 0, and the reverse. Okay, so here's our sine graph. Okay, it looks something like this. So this is the graph y equals sine of x. Alright, so question, does this graph that I'm looking for have an inverse? Does this graph that we're looking at, is it one-to-one? Does it pass the horizontal line test? The answer should be no. This function actually does not have an inverse. So sine of x does not pass the horizontal line test. So that means it doesn't have an inverse, it's not one-to-one. So why are we even learning about inverse trig functions? Well, in order to make it be one-to-one, we just can't use the whole function. We are going to restrict the domain of the function and then just use the inverse of that to be our inverse sine function. So let me write that down. So we will have to restrict the domain to find its inverse. Alright, so again, this function does not pass the horizontal line test. As we see, it crosses my horizontal line multiple times, so it doesn't have an inverse. However, we are going to restrict our domain from here, negative pi over 2, to positive pi over 2. And let's just look at the space between my two red lines here. So in the space here, does this restricted sine function pass the horizontal line test? The answer is yes. So we can take the inverse of this little piece. Okay, and that's what we're going to call our inverse sine function. So let's do two xy tables. So let's do first our restricted sine function. Okay. Alright, so we're going from negative pi over 2 to 0 to pi over 2. And the function values here are -1, 0, and 1. Okay, so when we write out our inverse, so we're going to use sine inverse to represent the inverse of our restricted sine graph. We just have to switch x and y. So all of these y values will be the x values for the inverse, and then all of the x values are now the y values for the inverse. Okay. So can you tell me the domain of this function of sine inverse? So what are the possible x values? Well, x values are always going to be between -1 and +1. And the range, the y values, will always be between -π/2 and +π/2. So we're going to return to the domain and range of this function later. But whenever we're talking about sine inverse, we are talking about the inverse of this restricted sine function. All right, so here's our definition. All right, it says the inverse sine function denoted by sine inverse. Also, you will see it as arc sine of our function is the inverse of our restricted sine function. All right, so just like we could rewrite natural log and just like we can rewrite logs and exponentials in terms of each other, we can do the same thing with our trig functions, right? So we can say y equals sine inverse of x means the same thing as basically switching x and y. Sine of y equals x. And so that's what we're going to be working with for our examples. So I kind of jumped the gun and I already told us the domain. All right, so the domain of our sine inverse function is from -1 to +1, and the range is from -π/2 to +π/2. So I do have a question for you. Is sine inverse of x the same as 1 over sine of x? Are these the same thing? Do they mean the same thing? Is this the same thing as the inverse of sine? Definitely not. This is the reciprocal. This thing is actually cosecant. So the answer is no. These two things are not the same. Okay, so next, let's do some examples. And I'll do it in the next video just so this one doesn't get too long.